So today we're going to look at position with constant acceleration motion. So the main question to ask is, how does the position change under constant acceleration? And this question can be answered by looking at the equation for the position describing the motion. And to find this equation, we can start with the average velocity equation. The average velocity is going to be equal to x2 minus x1, t2 minus t1, and then we can let x1 equal to x0, representing the starting position, and we can let t1 equal to 0, representing the starting time, and so we get the average velocity equal to x minus xo over t, and that'll be our first equation, where v average x is the average velocity, x minus xo is the displacement, and t is equal to time. So to find the position equation, we're going to need to derive a second equation. So to find the second equation, we have to use a property of constant acceleration, and that is that we have to note that the x velocity changes at a constant rate when acceleration is constant. So the equation v average equals 1/2 vox plus vx can be used, where vox is the initial velocity, vx is the velocity at position x, and v average is the average velocity. And I just want to know that this equation is only true when acceleration is constant, because essentially what we're doing is, since the velocity is increasing at a constant rate, the average is just going to be adding the velocity at position x and the velocity initial divided by 2. So that's what we're doing. We're saying that's what the average is. So now we have everything we need to solve for the position equation with constant acceleration. So we can start by putting our average velocity equation we just found. And I just want to note that we actually need the velocity equation for constant acceleration that we found in the last video, which is velocity equal to the initial velocity plus the acceleration times time. So if we plug that in for the velocity, we're going to get this expression here. And then we can add those two velocities to get 2 vox. And then we can distribute the 1/2 to each term. And we get 1/2 times 2 is just equal to 1. And then 1/2 times 1 is equal to 1/2. So we get that expression there. And then we can plug the first equation we found in for the average velocity. And we get this expression here. And then we bring t to the other side. And then we can distribute t into each term. And then we get this expression here. And then we could bring xo to the other side. And remember that when we bring it to the other side, it actually becomes positive. And then we arrive at the final answer, which is our position equation with constant acceleration. Note x represents the position at time t with constant acceleration. Note that this is only applicable when the acceleration is constant. Xo is the initial position, vox is the initial velocity, t is time, and ax is the constant x acceleration. One useful note I want to make is the position equation tells us that the object's position at time t is the sum of 3 terms. The xo, which is the initial position at time t equals 0. The voxt term, which is the displacement of the object if velocity remained constant. And then the axt squared term. This adds an additional displacement term, and it's caused by a changing acceleration. So these 3 terms, when they're added, add up to the final position.